Welcome to This Explainer. Today, we are unpacking something absolutely mind-bending, the Unified Dynamics Framework. We're going to look at a model that essentially reconstructs the laws of physics, quantum field theory, general relativity, the whole shebang, without a single arbitrary parameter. Imagine building the entire universe's operating system from scratch, using nothing but pure geometry. So let's just jump right in and challenge the oldest assumption in physics, the idea that reality is built on a smooth, continuous fabric of space and time. What if that smoothness is really just an operational fiction? What if at the absolute fundamental level, the universe is actually a discrete, capacity-limited information engine, functioning way more like a digital network than a continuous sheet? Right now, modern physics is kind of in a crisis. The Standard Model is incredibly successful, sure, but it essentially forces scientists to manually guess and plug in dozens of free parameters, like masses and coupling strengths, just to force the math to work. It's a bit like tuning a guitar by trial and error. Unified Dynamics completely rejects this approach. It generates reality strictly from geometric logic, predicting exact values with zero free parameters based purely on the combinatorial limits of a discrete network. Here is our roadmap for today. We're going to cover why physics needs a new paradigm, explore the discrete tetrahedral substrate, and then break down the exact primitives, derived structures, bridge candidates, and finally, how to falsify this entire model. Section 1. Physics needs a new paradigm. Imagine reality not as a smooth fabric, but as a vast digital network of nodes. And there's a hard computational bottleneck at play here, the vertex information capacity limit, mathematically locked at 7/768. When a single node overflows with too much state update information, it literally chokes. To survive, it has to push that data outward. And that outward push, that is exactly what we perceive as mass, distance, and time. Moving on to Section 2, the discrete tetrahedral substrate. Now, the 28 zero-parameter predictions of this framework aren't just random numbers thrown at a wall. As detailed in the framework's ledger, they are formally classified into 3 epistemic weight classes: 14 exact primitives, 6 derived structures, and 8 supported bridge candidates. And crucially, every single one of these is strictly derived from the combinatorial limits of a K4 discrete network. There is absolutely no empirical curve fitting going on here. Section 3. The 14 exact primitives. Let's look at the foundational structural constants of this geometry, starting with the number 192. This is the substrate state dimension. You can think of this as the absolute structural headroom, the maximum memory capacity of our underlying geometric grid. It's the baseline from which all other limits in the universe are calculated. Every single invariant we're looking at is generated purely by combinatorial geometry. Notice how that memory capacity of 192 interacts with the primal overlap deficit of exactly 7. When you divide them, you get the canonical master scalar of 7/192. From there, the math literally forces out 18 unaveraged transport vectors, an ultraviolet spectral dimension of 4/3, and, beautifully, exactly 3 macroscopic spatial dimensions. We don't just happen to live in a 3D universe. 3D space is mathematically forced into existence by this discrete network. So how does information actually move through the space? It's incredibly structured. We have a 2-step breathing sequence called triadic coboundary transport. First, an asymmetric expansion forces a volumetric multiplier of 4/3. Then, a symmetric edge co-compression throttles the channels inward by a factor of 3/2. This sequence acts like an algorithmic shock absorber. It irons out the wrinkles, which is exactly how we get the illusion of smooth, continuous motion from an inherently pixelated grid. Section 4. The 6 derived structures. Now we're looking at observables for low-energy interfacing, and here is a massive paradigm shift. Under unified dynamics, dark matter isn't some exotic, invisible particle we have to invent. It's literally just a structural fraction of the network itself. Because some nodes are charge neutral, they're invisible to electromagnetic forces. That mass-weighted neutral fraction comes out to exactly 43/228, which gives us a structural abundance of roughly 18.9%. Bam! No dark particles needed.
And look at these other highly specific macroscopic observables emerging naturally from the geometry. You get an exact atmospheric neutrino mixing angle of 45 degrees, a solar mixing angle of roughly 26.6 degrees, a reactor mixing angle of about 6.6 degrees, and a bare CP violating phase of exactly 60 degrees. Even the strictly attractive nature of gravity is proven by a gravitational sign invariant of -1, which is driven by negative boundary pressure gradients. Standard physics has to measure these in multi-billion-dollar labs. Unified dynamics predicts them purely from geometry.
Section 5. The 8 bridge candidates. These physical limits are structurally derived, but are still awaiting further measurement-facing mapping. They lay down a hyper-specific gauntlet for future physicists. We're talking about a predicted ground-state neutrino mass of roughly 35 millielectronvolts, a light-dark matter relic mass of about 2 megaelectronvolts, a Cabot angle parameter of 0.221, a heavy quark mixing angle of 2.50 degrees, a cosmological spectral index tilt of 0.93, and that universal heavy lift metric of 101/6. The math is quite literally waiting for experimental reality to catch up. Section 6. Falsifying the universe. Okay, so how do we actually test this? 800,000. That is the massive number of independent, highly chaotic state update samples that developers threw at this framework in the F6 falsifier simulation pipeline. They effectively stress-tested this geometric universe to see if it would instantly shatter or produce stable structures. And astoundingly, 94.07% of those highly chaotic initial states naturally collapsed into highly ordered topological configurations. And they did so exclusively at the n=7 pre-generational attractor boundary. This is incredible because it structurally resolves the vacuum state, what we'd call the Big Bang, without requiring any ad hoc cosmological inflation models. The network just naturally locks into stability at this exact threshold.
But the ultimate definitive test? It's out there in the stars. If upcoming cosmic microwave background observatories record a primordial tensor to scalar ratio signature of exactly 0.01765, well, the smooth space-time paradigm of the past century is dead. That specific signature will literally prove the universe is discrete.
So I want to leave you with this final paradigm-shifting question to ponder about the true nature of reality. Is the universe not a smooth fabric, but a capacity-limited, discrete information engine? If unified dynamics holds up to these extreme experimental benchmarks, we are going to have to completely rethink what it means to exist in space and time. Thanks for joining me on this explainer, and definitely keep your eyes on those upcoming polarization surveys.